Hey, what's going on, guys? We have this question right here is asking the length and the width of the cardboard are 20 feet. So they are saying the total distance is 20 feet, and 16 feet is the width, right? This is the width, and we are going to cut the corner and fold upside to the box. So they have given this is cut part and 60 minus 2 edge. This means this is going to be these two sides are edge. So this is edge. Let's mention that here. So this is edge and this is going to be edge. Therefore, we know the height of the box is going to be edge, and they are saying that determine the height of the box that will give the maximum value. So we have to find the height that's going to give this box the maximum value. So let's see how we can find this. So before I find this, since this is related to volume, I have to find the volume first. So in this case, what I can do is volume of the general formula for the volume of the box is width time length and the height. So in this case, what we have is we have the width that is 16 minus 2h. So I'm putting that one right here, 16 minus 2h, and we have the length that is 20 minus 2h. I put that one too. So it's 20 minus 2h, and we know the height is going to be h, right? And then if I multiply everything together, it comes out to be 4h cube, 4h cube minus 72h square plus 320h. Since everything is in the h, so we don't have to worry about, because sometimes we might get h time l and something like that, then we have to find everything in terms of h. So in this case, everything is in h, so we don't have to worry about that. So the question is asking, determine the height of the box that will give the maximum volume. So whenever they ask for maximum minimum, we have to go do the optimization, right? So in this case, to do the optimization, what you have to do is we have to find the absolute, and I have to find the absolute maximum. So to find the absolute maximum, first of all, I have to find the first derivative to check the critical points. So in this case, to take the critical points, I have to find the first derivative. The first derivative of this one is going to be 12h square minus 144h, and this is going to be just 320. And to find the critical points, we have to set this derivative equal to 0, because that's going to give the h critical points. Since this case, we have so let's set this one to equal to 0, and let's see, can we divide this one by any number? Yes, of course. If you think about it, we can divide this by 4. So if I divide this one by 4, what will we get? We will get here, this one comes out to be 3h square and minus 36h. This is gonna be 80. And then since we have this one, and it looks like it's hard to factor this one, because we have to get a number that's multiply these two, that should give 80, and when we add this would give us 36. It's look like I can't think of, no, not 80, it's 3 times 80 is 240, and when we add, it has to give 36. It looks very hard to find it. So in this case, what I can do is I have, from the elementary school, we have studied some formula that's called h is equal to minus b plus or minus square root of b square minus 4ac over 2a. So we can apply this equation, these values in this equation, to find this value, h value, right? So if I substitute all the values, so it's going to be, let's say, minus 36. That's my b, because this is, let's say, this is a, this is b, this is c. So this is going to be my b, and b square is going to be minus, is it minus 36? Yeah. So minus 36 square, minus 4 times a is 3, and c is going to be 80. And we divide this one by 2a, is this going to be 2 times 3, and if you find the value, it comes out to be 9.055, 2.945. We have two critical points right here, but before I go further, I have to check the domain, whether it's these two are in the domain. So to check the domain, what you have to do is, we know this box, like, you can't get the box with a negative dimension, for example, you can't get a negative 2 centimeter or something like that, right? So we know it should be greater than 0. And let's say this, so first of all we know h is greater than 0, greater than or equal to 0. Then 16 minus h also greater than or equal to 0. And if I solve this one, like 16 minus 2h, so if I solve this one, 16 is greater than 2h, and so 8 is, so h should be less than 8. So we have found something. And also if I solve 20 minus 2h greater than 0, I will get 20 is greater than 2h, therefore h is greater than 10, h is less than 10. And since we have less than 10 and less than 8, less than 8 is going to be dominating, therefore this is going to be something like this. So this is 0 should be, h should be greater than 0, but we should be less than 8. So it's going to be less than 8. So this is my domain. This is my domain. So let's check whether these two values are in the domain. So since the h should be less than 8, we can't have 9.055 because it's greater than 8. Therefore, we can't take this. So this is not a critical number, but this is going to be a critical number. But now in this case, what we have to do is we have this critical number, and let's check whether it is a absolute minimum or absolute maximum, because also we have to find the endpoints, right? So since we have these are the domains, these are the endpoints, 8 and the 0. So let's apply this endpoints in this equation, and let's see what we get. So if I apply the endpoint in this equation, I will get, so 4 times 0 cube minus 72 0 square plus 320 times 0, which is going to give me 0. That is one of my value. This can be absolute minimum or whatever. Okay, let's find the other value. The 4 times 8 cube minus 72 times 8 square plus 320 to 20 times 8. And this also, if you calculate this one, this also comes out to be 0. So these two are going to be absolute minimum because this is the lowest values, right? And if you find the h value, so if you calculate h value, therefore when you calculate h value, you will get, let's see, v 4 times 2 point, where's the value, 2.945 cube minus 72 times 2.945 square and 320 times 2.945. You will get a number, but that's going to be positive, but I can say it by the look of it. So that's going to be a positive number, but we have to check whether it is absolute, like, so first of all let's check this one. So I have to calculate this value. So wait a minute, I grab my calculator and solve this one. Okay, let's do this. So 4 times 2.945 cube minus 72 times 2.945 square plus 320 times 2.945. So which is giving me 420. So 420 0.11. Therefore we know this is my maximum value, therefore this is the absolute maximum. But the question is, determine the height of the volley box that will give the maximum volley. So the question is which height, the height of the box. So this is the height. So we found h, so h already, and this is the value. Therefore this is the final answer. H is equal to 2.945 is the value that is going to give the maximum volume. So that's the final answer. I hope you guys like this video. See you next time.